Hello, welcome to this class. I want to show you how to solve an electric circuit. In this question, we have been given an electric circuit with two cells, the EMF of each being 1.5 volts and 1.5 volts. The internal resistance of each of the cell is 1.5, 0.5 ohms and 0.5 ohms. We have four external resistors connected in this manner. So to solve this problem, the first thing we are going to do is to get the effective external resistance. Okay, but to do that, let's proceed this way. The total EMF is given as E1 plus E2 since the cells are connected in series, and that will give us 1.5 plus 1.5, and that will give 3.0 volts. And the total internal resistance is R1 plus R2, and that will be 0.5 plus 0.5, and that will be 1.0 ohms. Now, to get the net external resistance, we can look at the 3 ohm and the 2 ohm. They are connected in series, so we add this together. That will give us, maybe I say R1 equals to 3 plus 2, and that will give us 5 ohms. Now, this 5 ohms is now in parallel with this 1 ohm because as the current leaves from this, it flows this way. And on getting to this point, this is a junction, meaning the current will split, one to that side and the other here. So this section of the circuit is parallel to this section of the circuit. So we can have the parallel section, the net resistance along the parallel section as 1 over 5 plus 1 over 1. And 1 over R parallel will give us, here the SCM is 5. You have 1 plus 5. So you have your 1 over R parallel equals to 6 over 5. So the R parallel, of course, will give us 5 over 6. 5 over 6 ohms. Now, this entire portion of the circuit has a resistance of 5 over 6. Now, this, of course, will now combine to flow into the 4 ohm resistor. So the net resistance for this circuit, of course, will be R parallel plus R series. And this will be 5 over 6 plus 4. So the net resistance for this circuit, if you add this fraction and the number together, will have 29 over 6 ohm, which is the same thing as 4.83 ohms. So this is the net resistance for the circuit. Now, to compute the current, we know that current in a circuit with an internal resistance that is not negligible is given as I equals to E R plus R. So this gives us 3 over your 29 over 6 plus 1. This, of course, will give you 3 into, so this is 35 over 6. So the current in this circuit is 3 multiplied by 6 over 35. And this will give us, and this will give you 18 over 35 ampere, which of course is the same thing as 0.514 ampere. So this is a solution to the very first part of the question. So the current in the circuit, of course, is 0.514 ampere. The next part of this question is asking us to get the lost volts. Of course, we know the lost volts is a voltage drop due to the resistance in the electrolyte of the circuit, and it is given by current multiplied by net internal resistance, which will give us, the current is already 0.514, multiply this by 1, the net internal resistance, and this will give us 0.514 volts. So the internal resistance, the lost volt of this system is 0.514 volts. Now, the last part of the question is asking for the potential difference across the 4 ohm resistor. So from Ohm's law, we know that the terminal PD is given by V equals to IR. So the I is the current that flows into this 4 resistor, is a net current in the system, which of course is 0.514 multiplied with the resistance of interest, which is 4, and this will give us 2.056 volts. And that is the solution. I want you to take your time, look at the solutions, and subscribe to this channel so that we can get solutions to more problems. Thank you.